In this video, we are going to do properties, theorems, and definitions of circles, which is related to class 9th. Now, let's begin with the definition of a circle. What do we know or how to define a circle? So it says it's a collection of those points in a plane which are at a fixed distance from a given point. So why do I say that's a collection of infinite points? As you can see that there are infinite number of, like, it's a collection of those points, maybe whatever be these points, and these points are equidistant from a fixed point. You can see that all points, right, is fixed distance. It's at a fixed distance, and that fixed point is called what? The center of the circle, generally denoted by O, and this fixed distance is called the radius. So the fixed point is called the center of the circle, and the fixed distance is called the radius. Moving the next property, it says there is one and only one circle then that can pass through three non-collinear points. So let's say if I take any three non-collinear point in the plane, and if I draw a circle, let's say I've drawn a circle here, and check here, if I try making a circle so that or it passes through all 3 points, you can make only one circle, right? So if you try, like, there is one and only one circle. If you try making a circle, let's say I made one other circle, and say of whatever the radius you try, you see in this case it is meeting with these 2 points, and in case it is, even if it is extended, can meet. If you try making another circle so that it will pass through all 3 points, then these two circle will coincide. Right? That means they will be nothing but a congruent circle. So we'll say that only one and only one circle that can be drawn through three non-collinear points. Moving to the next. So this is the property and its converse. The property first says that equal chords of a circle. The property here is that equal chords of a circle subtends equal angle at the center. So what is the meaning of subtend here? Let's say if I make a circle here and I make 2 chords over here, and I'll keep the length of these 2 chords as equal. Let's say I made this chord, the first chord here, and maybe these chords parallel or not. So the the angle subtended by these 2 chords at the center. So let's say if I name this chord as AB, this being CD. So angle subtended by these 2 chords at the center, that means joining these points. So this is the angle subtended by the first chord, and this is the angle subtended by the other chord. What you have to remember that, say if I make this center as O, then if the length of the chords are equal, that means if you are given that AB is equal to CD, then using this property, I can say that is angle AOB will be equal to angle COD, right? So this is what the property says, that this angle will be equal to this angle. But remember, this is true when these 2 chords are equal. So if you are given this chord, let's say if I say about this chord here, the chord AB, and here the chord CD, right? Now, even the converse of this is true. So the converse of this is what? If the angle subtended by chords at the center are equal, then the chords are equal. That means converse to this, if you are given this, that these 2 angles, I repeat, the angle, if you are given that angle AOB is equal to angle COD, right? Then by property, you can say that AB is equal to CD. Well, this is not true for a pair of chord or 2 chords. This is true for any number of chords in a circle. So one last time, it says that equal chord subtends equal angle at the center. And it's only at the center, not in any other point or in the inside or outside. The third one here, which is in fact, I've taken a combination of 3 properties here. Let's begin with the first one. I made a circle first. Let's say if I make a circle. The first property says that the perpendicular from the center to a chord bisects the chord. So I took a circle and then I'm making any chord over here. Let's say any chord. Say AB, I made a chord here. And if I draw a perpendicular from the center, so you know what is a perpendicular. So if I draw a perpendicular on this chord from the center, a perpendicular is drawn from the center, say it is intersecting this at point M, that it means that AM is equal to BM. So repeating, the perpendicular drawn from the center bisects the chord. This is the first, and the second one is that the line joining the center to the midpoint of the chord is perpendicular to the chord. That means if you are given that if it is given to you that M is the midpoint of AB, right? If it is given to you that M is the midpoint of AB, and if you join the midpoint of the chord with the center, then this line joining the center to the midpoint of the chord should be perpendicular to the chord. So the result here, using this property, we can say that OM is perpendicular to AB. And finally, the third one here, if you look into the third, what is the third property says that? It says perpendicular bisector of a chord passes through the center of the circle. Now clubbing these two, what we have to do here is to draw a perpendicular bisector. So for example, if I say that we do not know the center of the circle, let's say if I say that I don't know the center of the circle, and if I draw the perpendicular bisector of this chord, like how do you draw the perpendicular of bisector of the chord? If you have used compass drawing a perpendicular, you can recall that we make an arc from A on one side and also on the other side using B, we cut these two arcs. And then we join these 2 points, right? So what you'll figure out that if a perpendicular is perpendicular bisector of a chord will pass through the center of the circle. The perpendicular bisector. So this time it is perpendicular as well as bisector, then it will pass through the center of the chord. Moving to the next. Next it says that equal chords of a circle are equidistant from the center. So equidistance implies are at equal distance. So once again, I'll make a circle over here and I make two chords over here. These two chords are equal in length. Let's say I take this chord as AB and I'll take another chord over here. Let's say CD, I've taken another chord, keeping in mind that these two chords are equal in length. Let's say O be the center of the circle. And by distance, you should remember that distance of a line from a point by default is perpendicular. I repeat, distance of a line from a point by default is perpendicular. So it means to say that, let me complete the diagram. If I say that O be the center of the circle, this is OM, this is ON. So if you are given AB equals CD, that means using this property, we can say that OM equals ON. Now, in fact, the converse of this is also true. It says that if you know that OM is equal to ON, or if it is given to you that OM is equal to ON, then using this property, we can say that chords which are equidistant from the center are equal. That means this time you are given OM is equal to ON, their distance from the center are equal. Then using this property, the result is the chords, that is AB is equal to CD. The third, which is combination of three I have taken. So if I read the first one, it says that two chords of a circle are equal, then their corresponding arcs are equal. So if I once again make a circle over here and I take two arc here. First I'm taking two chords. Let's say if I take two chords here, whether these two chords have a common point or not is not necessary. Let's say I take two chords over here and in this as AB and this chord as CD. So what does it mean here? It means to say that, let me make a small cut over here to make you understand that if you are given these two chords, say AB is equal to CD, then this arc, the arc here I'm talking about this arc. So arc here AB should be equal to this arc CD. These two arc will be equal, and as I said, this is true only when these chords are equal. So the length of these chords, say AB, if it is equal to the length of the other chord CD, then the arc are also, the arcs are equal. So the result is what? First you'll write if AB is equal to, this is if AB is equal to CD, then the arc AB, which is denoted like this, is equal to arc CD. Well, its converse is also true. So if in case if you are given that arc AB is equal to arc CD, then the result is the chords AB will be equal to chord CD. Now the last one, it says the congruent arcs subtends equal angle at the center. So by congruent arc, what does it mean? That arcs are congruent means the arcs are equal. So let's say if I take AB and CD as two arc over here, look into the figure. If I say AB is the green one, so and let's say this be the center of this circle, then joining these two, the angle so made here, right? This angle should be equal to angle COD. So that means if you know that these two arcs are equal, then the angle subtended by these two arcs will also be equal. Moving to the next, this is the most important property called the alternate segment. So and to understand this, once again, I'll make a circle first. And I first make a minor and major arc here. So I cut a small portion of it, indicating that this is the minor arc. And the minor arc I am painting as or coloring as white over here. This is arc AB here. And say it is subtending an angle at the center. And the angle subtended by these two chords at the center. Let's see if I mark this as AOB. So this is the angle subtended by this arc at the center. So the angle subtended by arc at the center, it says twice the angle subtended by the same arc on the remaining part of the circle. Now, very important to understand that what is it remaining part means? That means if we are considering this arc, the painted white over here, the remaining part is this, right? So one more time, if I say that if I'm considering the angle subtended by this arc, which I painted white, right? And then the remaining part is what? This portion which is painted golden. So we'll say that the angle subtended by this angle AOB, let's say I took many points, right? Not only one, say 1, 2, 3, and I mark this as C, P, D. Then what does it mean that this central angle, that is AOB, will be twice the angle subtended by these. That means, so let me first complete the diagram and then I'll explain you. So I'm joining this point. These are what? I'm subtending angle with this arc on the different different arc over here. So that means this angle, the angle subtended by this arc at the center, so this angle, right? This will be twice the angle subtended by this. Alternately, I can say it is twice of, alternately, I can say this is twice of, yeah, twice of this as well, right? It should also be, it should also be twice of this. So because these points that is taken, say C, P, D, are on the remaining part of the circle. That's called the alternate segment. Now, if I use this concept of alternate segment, there are two more properties that can be derived using this alternate segment. So let's figure out. But before that, let's do one more part on this question. Now consider I took a point once again at the center, and this time I'm joining these two points with the center so as to obtain an angle. And I'm talking about the angle subtended by this major arc here. That is the one which is colored golden here. So if I ask you what is the angle subtended by this arc, the major arc AB at the center, many of you will say angle AOB, but that's not true. It is reflex angle AOB, as it is more than 180. So now we are talking about the angle subtended by this major arc at the center. Then this angle, that is reflex angle AOB, will be twice the angle subtended by the same chord on the remaining part of the circle. So by remaining part of the circle, it should be anywhere over here. So if I make the angle subtended by this chord at the other portion, it has to be what? It should be this. Or maybe if I take another point over here, it should be this. So we can say that, assume if I take this angle, say as 170 degree. So since this angle is twice of this, alternately, we can say that this angle will be half of this. So this will be half of 170, and that's what, 85? It should be 85. So this is what? Alternate segment. Now, based on this alternate segments, two more properties are derived. Let's figure out which are these two properties. From same alternate segment, two more properties. Now for that, let's come to the two more properties, as I said. Here, the first one, as I said, are two angles on the same segment of the circle are equal. So consider this time the arc AB here, and I'm going to, using this arc AB, I take 2 points, say here P, and the other points I take this point as Q. Now if I join this, I get two angles over here. Let's say one is angle AOB, this angle AOB, and the other which I make over here is this. Now what you can check here, that these two angles are equal. That is, angle in the same segment are equal. But this actually is derived from the same property which I just discussed, called the alternate segment. So why is it so? Let's figure out. Over here I said that this angle, say AOB, using alternate segment, I said angle AOB should be what? Twice of angle APB. And using the same property, I can say that angle AOP should be what? Twice angle AQB, using alternate segment. As you can see, this is these two angle APB and AQB are on the same segment. Now from these two equations, what you can see, their LHS are same. So twice angle APB is equal to twice angle AQB. So if I cancel this 2, what you can figure out, that angle APB is equal to angle AQB. This is the first one. Now let's come to the next property, which is again derived from here, that is angle in the semicircle is right angle. So understand the meaning of angle in a semicircle first. So once again, I'm going to draw a circle first. Let's say I draw a circle over here. And just to understand, I make a small cut over here and here, representing this is the diametric end. Then you can see that it is actually a circle split into two equal half and each representing the semicircle. So let's say if I even draw the diameter, I've drawn the diameter here. This is what the diameter center has to be somewhere here only. And if I talk about the semicircle, there are two semicircles over here. Let's say the one is this and the other is this. Now, if I ask you what is the angle subtended by, if I ask you the angle subtended by this lower semicircle, right, at the center, I repeat, what is the angle subtended by this lower semicircle, the white one, at the center? You should say that this angle, right, subtended by this will be above, right, above this angle. And if I ask you what is the angle subtended by this same semicircle is also an arc, so you can use arc, same arc on the remaining, as I said, I've taken the white semicircle, then it's the golden one is the alternate segment, right? So if I talk about the angle subtended by this arc AOB, this is arc, sorry, AB. At the center, you should say AOB. Clearly, this is AOB. So by property of alternate segment, you should say it should be what? Twice of angle APB. And what is AOB? As you can see, this is a straight line joining three non-collinear points as it is a diameter. So you know that I can replace this with 180 degree. As you know that in a like three cool these are what? A straight line, right? A straight line. So angle AOB by linear plates 180 degree. So this is what? This is twice of angle APB. This is twice of angle APB. So if I reduce, what we get angle APB as 90 degree. So we say that angle in a semicircle is right angle. But then anywhere, right? So if I take any other points here, let's say these are the points I have taken. So if I join this with this, so this angle will also be 90 degree. So will be this. So you can just think about if one point is on the circle and the other 2 points are ends of the diameter. Other 2 points are the ends of the diameter, then this angle subtended will be 90 degree. So we say that its property which you are going to write in the exam is angle in a semicircle is right angle. Check for more. Yes, we have one more. Now next is cyclic quadrilateral. So what is a cyclic quadrilateral? The definition first I'll tell you that quadrilateral whose all four vertices are on the circle. So it's on the circle means, let me first draw a circle. Now let's say I took any 4 points on this circle, say one over here, right? Irrespective how they are going to form, and I try making a quadrilateral by joining these 4 points. Okay, so let's say assume if I use straight line only, joining them, and this as well. Okay, and if I name this as ABCD, as you can see, all four vertices are on this circle. So it's what? It is a cyclic quadrilateral. Now, when I say it's a cyclic quadrilateral, you should remember that all four vertices should be on this circle, right? It should be on this circle and not inside. Like in this case, you can see that if I displace it slightly so as, or let's say if I make it like this, even if the 3 points are on the circle and one is on the interior of the circle, so it's not a cyclic quadrilateral. Similarly, even if 2 points are on this circle, or say 3 points on this circle, but the fourth point is outside, then it is not a cyclic quadrilateral. So many of you get confused when a cyclic quadrilateral is given. It's not a quadrilateral which is inside a circle. It's a quadrilateral whose all four vertices should be on the circle, has to be on the circle. That's what a cyclic quadrilateral is. Now, if you talk about its property, the property is that the sum of the opposite angles is equal to 180 degree. So opposite angles are supplementary. Remember, they are not equal. They are supplementary. That means angle A plus angle C is equal to 180 degree. And it is supplementary. Well, it's easy to understand. If this is 70, it has to be 110. And conversely, or otherwise, I can say if this is 60, then it will be remaining, that is 120 degree. Repeating that opposite angles are not equal, their opposite angles are supplementary. So similarly, angle B plus angle D will be 180 degree. And the converse is also true. The converse is also true. That means even if it is not given a circle, like even if there is no circle, as you can see, this next time I'm going to draw quadrilateral, alone quadrilateral. Let's say I make one quadrilateral, and that's any quadrilateral. So I name it as A, B, C, D. And if you're given that this angle is, say, for example, 55 degree, right? So this one angle is given as 55 degree, and let's say the other is given as 125. The other, I mean to say the opposite angle here, 125 degree. Then on adding these two angles, let's say angle A plus angle C, what I'm getting is 55 plus 125, right? That's 180 degree. So therefore, you can say that, therefore, ABCD is what? Is a cyclic quadrilateral. Well, it's not necessary that their circle has to be there in the diagram, right? It's just that if even any one pair of opposite angles uh, are supplementary, that means if the sum of opposite angles of a quadrilateral is 180 degree, then we say it's a cyclic quadrilateral. I think this much only. We'll do MCQ in the next video.